3 weeks ago, the White House quietly signed 2 executive orders that almost nobody outside a small circle of defense contractors and physicists actually noticed. And just days ago, the National Security Agency and the United States Army followed up with an announcement that confirms exactly how serious this entire situation has become. Together, these 2 moments form what can only be described as the second chapter of a story that started building months earlier, one that could fundamentally reshape how America defends itself for the rest of this century. If you care even a little bit about technology, national security, or where your tax dollars are actually going right now, this is a story you genuinely need to understand. Let's rewind to where this all actually began, because understanding Chapter 1 makes Chapter 2 make a lot more sense. Back in May of this year, the Department of Commerce announced a funding package worth just over $2 billion distributed under the CHIPS and Science Act, aimed squarely at building out America's domestic quantum computing industry. 9 separate companies received funding, along with 2 dedicated quantum chip foundries. IBM alone received a full $1 billion to build an entirely new subsidiary focused on manufacturing quantum-grade superconducting wafers. Global Foundries received $375 million to establish the country's first dedicated quantum foundry. The remaining funds were split across 7 additional companies, including familiar names like D-Wave, Rigetti, PsiQuantum, and Quantinuum, each receiving up to $100 million to tackle specific, unresolved engineering problems standing between today's experimental quantum hardware and tomorrow's fully functional machines. At the time, that funding announcement felt like a significant but somewhat isolated moment, the kind of headline that flashes across financial news for a day or two and then quietly fades from public attention. What almost nobody realized back in May is that this was never meant to be a standalone event. It was the opening move in a much larger, much more deliberate strategy, and the second chapter of that strategy just arrived with considerably more force than the first. It is worth remembering just how sharply the market reacted to that initial May funding announcement, too, because that reaction itself told a genuinely important story about how seriously investors were already starting to take this entire sector before the government's broader intentions became fully clear. Shares of the companies receiving funding surged dramatically within just 2 trading days, with some pure play quantum stocks climbing more than 60% almost overnight. That kind of explosive, immediate market reaction typically only happens around genuinely category-defining news, not routine government grant announcements, and it should have been an early signal that something considerably bigger than a simple funding round was quietly taking shape behind the scenes. On June 22, 2026, the White House released 2 formal executive orders that moved quantum computing from being simply a well-funded research priority into something considerably more significant, an official codified pillar of United States national security and industrial policy. The first of these orders, titled Ushering in the Next Frontier of Quantum Innovation, established something called the Quantum Computer for Application Development and Discovery Science Program, an initiative that directs the Department of Energy, working directly alongside the Department of Defense, the Department of Commerce, and America's intelligence agencies to develop quantum computing systems specifically capable of tackling problems no classical computer could ever realistically solve. This is not a vague, aspirational goal buried in bureaucratic language either. The order specifically directs the Secretary of War, the modern successor title, to what most people still think of as the Secretary of Defense, to establish concrete programs and capabilities specifically aimed at advancing military readiness for quantum computing applications. The second executive order tackles a completely different, arguably even more urgent piece of this puzzle, cryptographic defense. This order directs federal agencies across the entire government to begin actively migrating their highest value, most sensitive systems away from today's encryption standards and toward what is known as post-quantum cryptography, encryption specifically designed to remain secure even against a sufficiently powerful quantum computer. If that sounds like an abstract, distant concern, it genuinely is not. Security researchers have spent years warning about something called harvest now, decrypt later, a strategy where sophisticated adversaries quietly collect and store encrypted data today, betting they will eventually be able to crack it open once quantum computers finally catch up to the task. Sensitive government data encrypted using today's standards could theoretically be exposed within the coming decade, if that migration does not happen fast enough, which is exactly why this second executive order carries genuine urgency, rather than functioning as some distant theoretical planning exercise. Think about the practical scope of what a migration like this actually requires across an organization the size of the entire United States federal government, because the scale genuinely helps explain why officials felt compelled to formalize this transition through a presidential executive order, rather than simply leaving it as a quiet, lower priority. Technical recommendation buried somewhere, inside an agency memo. Every single government system currently relying on today's encryption standards, spanning classified military communications, intelligence gathering infrastructure, weapon systems controls, diplomatic cables, and even routine administrative databases handling sensitive personal information, potentially needs to be identified, prioritized, and systematically migrated to new quantum-resistant standards over the coming years. That is not a simple software update rolled out overnight. It is a genuinely massive, multi-year undertaking touching nearly every corner of the federal government simultaneously, which is exactly the kind of complex, sprawling challenge that benefits enormously from clear, unified executive direction rather than being left to each individual agency to figure out independently on its own separate timeline. Now here is where Chapter 2 of this story picks up real momentum, because executive orders alone do not build anything. They set direction and intent, but somebody actually has to execute on that direction. And that is precisely where the announcement from just days ago comes into play. On July 1st, 2026, the Laboratory for Physical Sciences, a specialized research arm operating under the National Security Agency, announced a joint initiative with the United States Army's Combat Capabilities Development Command Army Research Office. The program carries a genuinely memorable name, Quantum EAGL, standing for Quantum Ecosystem, Advancement, Growth, and Leadership, and it represents the first concrete, actionable follow-through on the broader strategy the White House laid out just over a week earlier. Quantum EAGL is not simply another vague funding announcement thrown into an already crowded field of quantum initiatives. It is structured around 5 genuinely specific, clearly defined areas of focus, each one targeting a distinct weak point currently standing between America's quantum ambitions and America's quantum reality. The first area is industry engagement, deliberately building closer working relationships between government researchers and private quantum companies to make sure research efforts actually align with what industry genuinely needs to succeed commercially, rather than government and private industry working in disconnected, parallel silos the way so many previous technology initiatives unfortunately have. The second focus area involves developing detailed commercial roadmaps, working hand in hand with private industry partners to identify exactly which specific technical challenges are actually blocking progress toward practical, scalable quantum computers, rather than simply throwing money at the problem in a general, unfocused way and hoping for the best. The third area, and arguably the single most strategically significant piece of this entire initiative, is supply chain advancement, specifically aimed at enhancing the performance, manufacturing capacity, and commercial availability of the highly specialized components required to actually build a working quantum computer, ensuring the United States maintains a genuinely robust, self-sufficient domestic supply chain, rather than remaining dependent on foreign sources for critical components. That supply chain focus deserves a moment of real attention, because it directly echoes a pattern national security officials have been increasingly vocal about across nearly every advanced technology sector in recent years. A quantum computer is not simply a single, self-contained piece of hardware. It depends on an enormous web of highly specialized components. Things like dilution refrigerators capable of cooling systems down to temperatures colder than deep space, ultra-precise control electronics, and specialized photonic components that only a small handful of companies worldwide currently know how to manufacture reliably at scale. If a hostile foreign power were ever able to restrict America's access to even a handful of these critical components, it could meaningfully slow down the entire domestic quantum industry, regardless of how much raw research talent or funding the United States otherwise has available. Quantum EAGL is explicitly designed to close exactly that vulnerability before it ever becomes a genuine crisis. This concern is not purely hypothetical either, and recent history in adjacent technology sectors offers a genuinely instructive cautionary tale worth understanding here. The global semiconductor industry spent years learning exactly this lesson the hard way, discovering just how dangerously concentrated critical manufacturing capability had become in a small handful of specialized facilities located in politically sensitive regions, a vulnerability that turned into genuine supply chain crises during periods of geopolitical tension and global disruption alike. Quantum computing hardware depends on an even narrower, more specialized set of manufacturing capabilities than conventional semiconductors currently require, meaning the strategic stakes of getting supply chain resilience right this time around are arguably even higher than the lessons the broader technology industry already painfully learned once before. The fourth focus area centers on algorithmic applications, specifically working to discover novel algorithms capable of delivering genuine quantum advantage, meaning calculations a quantum computer can meaningfully outperform any classical computer on, alongside developing better error correction techniques, since quantum systems remain notoriously fragile and prone to computational errors that classical computers simply do not have to contend with in the same way. The fifth And final focus area involves foundational research, ensuring the underlying physics and engineering breakthroughs still needed to make fault-tolerant quantum computing a genuine practical reality continue receiving dedicated, well-funded attention rather than being treated as a lower priority compared to more immediately commercializable projects. Taken together, these 5 focus areas reveal something genuinely important about how officials designing this initiative actually think about the quantum computing challenge as a whole, rather than viewing it as a single monolithic problem that simply needs more money thrown at it. Industry engagement and commercial roadmaps address the coordination problem, making sure government research dollars and private sector commercial priorities actually point in the same direction instead of quietly working at cross purposes. Supply chain advancement addresses the vulnerability problem, recognizing that even brilliant research breakthroughs mean very little if the physical components needed to actually build working hardware remain scarce, expensive, or dependent on potentially unreliable foreign suppliers. Algorithmic applications and foundational research address the genuine scientific problem, acknowledging honestly that quantum computing still faces real, unsolved physics and engineering challenges that no amount of funding alone can simply purchase a shortcut around. This is a genuinely more sophisticated, multi-dimensional approach than earlier government technology initiatives have sometimes managed to achieve, and it suggests the officials designing quantum EAGL learned real lessons from watching previous coordinated national technology pushes succeed and occasionally stumble. According to NSA officials directly involved in launching this initiative, the program builds on decades of foundational quantum information science research. The Laboratory for Physical Sciences has already conducted in close collaboration with the Department of Defense. Lee G. Samuel, the NSA's chief of the Laboratory for Physical Sciences, described quantum EAGLI as representing a significant expansion of the agency's broader quantum computing efforts, specifically designed to cultivate a resilient domestic industrial base capable of actually delivering on quantum computing's promise for both national and economic security simultaneously. On the Army side, officials involved in the program emphasized that working closely with the broader quantum industry would help strengthen America's supply chain, accelerate development of cutting-edge algorithms, and help overcome fundamental research challenges that no single organization could realistically tackle entirely on its own. One particularly interesting detail buried inside this announcement deserves real attention, because it reveals exactly how the government intends to actually execute this initiative in practice, rather than simply announcing lofty goals and walking away. Quantum EAGL will leverage what are known as flexible contracting authorities, essentially streamlined procurement mechanisms that let government agencies work directly and rapidly with private quantum companies without getting bogged down in the notoriously slow, bureaucratic contracting processes that have historically made it genuinely difficult for cutting-edge startups to work efficiently with the federal government. The Army Contracting Command has already posted a formal special notice on the government's procurement website, signaling that this program is moving from concept directly into active execution, rather than lingering in planning stages for months or years, the way so many previous government technology initiatives unfortunately have. So why does all of this genuinely matter for America's broader defense posture, beyond simply being an interesting story about government funding and executive orders? The honest answer touches nearly every domain of modern military and intelligence. Operations simultaneously, and understanding the full scope helps explain exactly why this issue has moved so quickly from a niche research topic into a formal presidential priority within just the past few months. Quantum computing threatens to eventually break the encryption protecting nearly every sensitive government communication, weapon system control network, and intelligence database currently in operation, which is precisely why that second executive order on cryptographic migration carries such genuine, immediate urgency. Quantum sensing technology, a close cousin of quantum computing that often gets less public attention, promises dramatically more precise navigation systems that could function reliably even in environments where GPS signals have been jammed or spoofed by an adversary, a genuinely critical capability for military operations in contested regions where reliable positioning currently cannot always be guaranteed. It is worth pausing on quantum sensing specifically for a moment, because it genuinely deserves more public attention than it typically receives compared to its flashier cousin, quantum computing. Traditional navigation systems rely heavily on satellite signals that can be jammed, spoofed, or simply disrupted by a sufficiently capable adversary operating in contested territory, creating real dangerous blind spots for military units, ships, and aircraft operating in exactly the kind of high-stakes environments where reliable positioning matters most. Quantum sensors work on a fundamentally different principle, measuring incredibly subtle changes in gravitational and magnetic fields with a level of precision no classical sensor can currently match, potentially allowing military systems to navigate accurately, even when every external signal has been deliberately cut off or corrupted by hostile jamming. This is exactly the kind of dual-use technology that rarely makes flashy headlines the way a raw quantum computing breakthrough does, but genuinely matters enormously to military planners thinking seriously about operating in contested, communications-denied environments. Quantum computing also holds enormous potential for solving complex optimization problems relevant to military logistics, supply chain routing, and resource allocation at a speed and scale no classical computer could realistically match, potentially transforming how military planners coordinate everything from troop movements to equipment maintenance schedules across a genuinely massive, globally distributed defense apparatus. And perhaps most significantly, from a pure national security competitiveness standpoint, quantum computing represents exactly the kind of foundational dual-use technology where whichever nation achieves meaningful advantage first could gain lasting strategic leverage across military, economic, and intelligence domains. Simultaneously, the same category of technology that historically justified enormous coordinated national investment during eras like the original space race or the early development of nuclear technology. This urgency becomes even more understandable once you look at the actual data on how seriously federal agencies are already treating quantum computing internally, well before this latest wave of executive orders and initiatives arrived. According to a recent survey conducted by the technology research firm IDC, covering more than 500 United States among federal agencies specifically, that number climbs considerably higher, to nearly half, with an additional 40% stating anymore. Real government agencies are already actively experimenting with real quantum systems today, and that existing momentum is exactly what programs like Quantum IEGL are specifically designed to accelerate and properly coordinate going forward. It is worth appreciating just how quickly that adoption curve has moved compared to how most emerging technologies typically get. Infrastructure has a long, well-documented reputation for moving slowly, often lagging years or even decades behind private sector adoption of new technology due to legitimate security concerns, complex procurement rules, and deeply entrenched legacy systems that cannot simply be replaced overnight without enormous risk and cost. Seeing nearly half of federal agencies already running active quantum pilot programs, with another 40% planning to follow within the next 2 years, represents a genuinely unusual pace of adoption for exactly this kind of institutional environment, and it strongly reinforces the broader argument that officials across modernization project would normally receive. It is worth pausing here to genuinely appreciate just how quickly this entire policy landscape has shifted over an extremely short window of time, because the pace itself tells you something important about how seriously officials across multiple different agencies are treating this issue right now, in roughly 6 funding individual private companies, to establishing formal presidential level policy direction, to actually standing up a dedicated interagency execution program bridging the NSA and the Army. That is a genuinely fast progression by the standards of how the federal government typically moves on complex technology policy, and it strongly suggests officials across multiple agencies view the underlying quantum computing race as considerably more time-sensitive than the general public discourse around this topic has generally reflected so far. Let's talk about what this specifically means for the broader quantum computing industry itself, beyond just the direct defense and security angle, because the ripple effects here extend well past government agencies and into the commercial companies actually building this hardware. For a sector where nearly every major pure-play company still burns through significant cash reserves without yet achieving meaningful profitability, having this level of coordinated federal policy support behind it provides something genuinely valuable that pure private sector speculation alone could never fully deliver: a real, tangible floor underneath long-term investor confidence in the sector's continued viability. When the federal government commits real capital, real executive-level policy direction, and now a dedicated interagency execution program, all within the same tight 6-week window that sends an unmistakably clear signal to private investors, to allied foreign governments, and frankly, to competing nations as well, that the United States considers quantum computing leadership to be a genuine, non-negotiable strategic priority, rather than simply one interesting emerging technology sector, among many others competing for attention and funding. It is also worth being honest and clear-eyed about the genuine challenges still standing between where the industry currently sits and where these ambitious executive orders ultimately want it to end up. Truly fault-tolerant, broadly useful quantum computers, capable of reliably outperforming classical computers on genuinely valuable real-world problems, remain, by most credible expert estimates, still years away from full practical maturity, regardless of how much funding or Coordinated policy support gets thrown behind the effort in the meantime. Quantum error correction remains a genuinely difficult, unsolved engineering challenge at the scale ultimately required for truly practical applications. Supply chains for the highly specialized components quantum computers depend on remain genuinely fragile and concentrated among a relatively small number of specialized suppliers worldwide, which is exactly why Quantum Jaeger specifically targets that vulnerability as one of its 5 core focus areas rather than treating it as a minor, secondary afterthought. It is genuinely worth being specific about exactly what these remaining technical hurdles actually look like in practice, rather than simply gesturing vaguely at difficulty, because the specifics reveal exactly why programs like this one need to run for years, rather than months before delivering their full intended impact. Building a genuinely fault-tolerant quantum computer requires linking together enormous numbers of individual physical qubits just to create a much smaller number of stable, reliably functioning logical qubits, since individual qubits remain notoriously prone to losing their delicate quantum properties from even tiny amounts of heat, vibration, or electromagnetic interference. Current error correction techniques, while improving steadily year over year, still require genuinely enormous overhead ratio between physical and logical qubits to achieve the level of computational reliability required for truly practical, valuable real-world applications. Closing that gap represents one of the single hardest, most consequential unsolved engineering challenges in the entire field, and it is precisely the kind of problem that benefits from the sustained, well-funded, multi-year foundational research focus Quantum Jaeger explicitly commits to supporting. None of these genuine, real challenges make this entire coordinated push somehow meaningless or purely symbolic gesture, though, if anything, they help explain precisely why the federal government chose to move now, deliberately getting ahead of these hard, unsolved technical problems while there is still meaningful time to build genuine domestic capability, rather than waiting until a foreign competitor achieves a decisive, potentially unrecoverable head start. And America finds itself playing an increasingly difficult game of catch-up on a technology with such enormous, wide-ranging strategic implications across nearly every domain of national security and economic competitiveness. There is also a genuinely important broader geopolitical backdrop worth understanding here, because none of this policy activity is happening inside a vacuum, disconnected from what other major world powers are simultaneously doing in this exact same technology space. Other major nations, most notably China, have been pursuing their own extremely well-funded, top-down coordinated national quantum computing strategies for years already, treating quantum technology as an explicit strategic priority backed by tens of billions of dollars in cumulative government investment across research infrastructure, domestic manufacturing capability, and dedicated national laboratories. Washington's rapidly accelerating policy response throughout 2026, culminating in this latest Quantum Jaeger initiative, reflects a clear, deliberate recognition that America cannot simply assume its historical technological leadership will automatically persist without genuinely sustained, coordinated national investment, specifically matched to the scale and seriousness of what rival nations are simultaneously building on their own side of this exact same technological race. It is worth understanding just how directly competitive this specific dynamic has genuinely become in practice, because it is not simply an abstract policy comparison playing out in separate national strategy documents that never actually interact with each other. When Washington announced its initial $2 billion quantum funding package back in May, markets on the other side of the Pacific reacted almost instantly, with Chinese quantum computing stocks surging significantly within just a couple of trading days, as investors correctly anticipated that Beijing would respond with its own accelerated push to avoid falling behind. That kind of immediate mirrored market reaction reveals just how closely both governments and the global investment community, watching both of them simultaneously, now track every meaningful policy move each country makes in this specific technological arena, treating quantum computing leadership as a genuinely zero-sum, high-stakes competition rather than simply parallel, independent national research efforts happening to unfold around the same general time period. So what should you actually take away from this entire story, now that we have walked through both chapters of exactly how we got here? First, understand that quantum computing has genuinely and decisively moved beyond being simply an interesting emerging technology story confined to specialized science publications and investor newsletters. It is now formally, officially embedded inside the United States national security policy at the very highest levels of government, backed by real executive orders, real dedicated funding, and now a real, actively executing interagency program specifically designed to translate broad policy intent into concrete, measurable technical progress. Second, understand that the specific structure of quantum Hegel, with its deliberate, explicit focus on supply chain resilience alongside pure research advancement, reflects genuinely hard-earned lessons learned from previous technology competitions, where America found itself dangerously dependent on foreign suppliers for genuinely critical components, a mistake officials are clearly determined not to repeat in this specific technological domain, given how much strategic weight now rests on it. Third, and this is perhaps the most important practical takeaway for anyone watching this video, with a genuine longer-term interest in where this technology and this broader industry are actually heading, expect this pace of coordinated policy activity to continue accelerating rather than slowing down anytime soon. The 6-week sprint from initial funding announcement through executive orders and finally to Quantum Hegel's formal launch represents a genuinely unusual, deliberately compressed timeline by typical federal government standards. And it strongly suggests officials across multiple different agencies view themselves as currently operating against a real, meaningfully ticking clock rather than working towards some comfortably distant, low-urgency deadline sitting safely years off in the future. For anyone working in or around the defense technology sector specifically, whether as an investor, an engineer, or simply someone tracking career opportunities in an emerging field, this entire sequence of events represents a genuinely significant signal, worth taking seriously. Programs like Quantum Hegel, explicitly designed around flexible contracting authorities and direct industry engagement, suggest the federal government is actively looking to bring outside talent and outside companies into this effort more quickly and more directly than traditional, notoriously slow defense procurement processes have historically allowed. That kind of deliberate structural change, prioritizing speed and direct industry collaboration over conventional bureaucratic caution, often signals genuinely real opportunity for organizations and individuals positioned to move quickly and engage constructively with exactly this kind of newly opened, actively welcoming government pathway. If this story genuinely helped you understand exactly how quantum computing evolved from a niche, specialized research topic into a formally codified pillar of American national security policy within the span of just a few short months, do us a solid favor and hit that like button right now, because stories like this one deserve to reach far more people who are still only thinking about quantum computing as some distant, futuristic curiosity, rather than the urgent, unfolding present-day reality it has genuinely become. And go ahead and subscribe too, because Chapter 3 of this exact story is almost certainly already being written right now, quietly, inside government offices and defense contractor facilities. Most of us will never actually get to see directly for ourselves. At the end of the day, what makes this specific story genuinely worth paying close attention to is not really any single executive order or any single funding announcement taken entirely on its own. It is the unmistakable, accelerating pattern connecting all of them together into one coherent, deliberate strategic arc. From individual company funding to formal presidential level policy to an actively executing interagency program, bridging the National Security Agency and the United States Army, all compressed into a genuinely tight 6-week window. America is not merely talking about quantum computing as some abstract future priority anymore. It is actively, deliberately building toward it, piece by piece, right now, in real time, with the outcome of this exact race carrying implications that could quite realistically shape the balance of global power for decades to come. Chapter 1. This story took years of foundational research quietly building in the background before it finally broke into public policy consciousness this spring. Chapter 2 moved considerably faster, compressing funding, formal policy, and actual execution into a matter of mere weeks rather than years. If that accelerating pattern genuinely continues, Chapter 3 may well arrive faster than most of us currently expect, and whoever is paying close enough attention to see it coming will have a genuine, meaningful head start on understanding exactly where this entire technology and the broader balance of global power riding alongside it is actually heading next.